In this video, we're going to be talking about how to derive the quadratic formula. And in the past, we've gotten comfortable using this quadratic formula. This is the formula we call the quadratic formula to find solutions to a quadratic equation. In other words, when we're given a quadratic equation in the form ax squared plus bx plus c equals 0, something like this one here, 4x squared plus 4x plus 2 equals 0, this is a quadratic equation because we have the x squared term, we have the x term, and then we have this whole number constant, and we have coefficients in front of the x term and the x squared term. So this is a quadratic equation because it's in this specific form here. When we have a quadratic equation in this specific form, we can use the quadratic formula, which is this equation here, to find solutions to the equation. So the values of x, to find the values of x that make this equation true. Now, many times we're able to just factor the left-hand side and then set the factors individually equal to 0 using the zero theorem to find out which values of x make this equation true. But sometimes we're not able to factor the quadratic equation, and in that case we can do one of two things. We can use the quadratic formula to find solutions, or we can complete the square and find the solutions that way. Well, as it turns out, the way that we find this quadratic formula, the way that we derive this quadratic formula, is just by completing the square with the standard form of a quadratic equation. So I want to show you how to do that so that you get a better understanding of why this quadratic formula here is true. So we already have this quadratic formula, but what we're going to do is complete the square of this quadratic equation, and eventually we're going to end up at this formula. So here's what that looks like. Remember when you complete the square that you want the constant, the whole number, on the right-hand side. Right now we have this positive c on the left-hand side, so we want to go ahead and subtract c from both sides in order to move it to the right. So we're going to get positive c and negative c to cancel on the left, and we're just going to be left with ax squared plus bx is equal to 0 minus c, which is just negative c. Then remember also that when you're completing the square, you have to have a coefficient of 1 on this x squared term. Well, we don't know if a equals 1, so we need to make sure that we divide everything through by a to remove the coefficient of a from this x squared term. So we're going to divide everything by a so that we can cancel a from the numerator and denominator of this first fraction, leaving us with just x squared. Then for this term here, we're going to separate the x from its coefficient. The coefficient will be the b over a, and then that's multiplied by x. And on the right-hand side, we have negative c over a. Now we have the left-hand side in a form where we can complete the square. At this point, what we're looking at is the coefficient on our first degree x term. And this process starting now is just the process we use every single time to complete the square. So if you're not familiar with completing the square, then this will look foreign to you. But otherwise, this is exactly what you're going to do every time. So we're going to take the coefficient on our first degree x term. In this case, that's b over a. And we're going to divide that by 2. So we're going to say b over a divided by 2. Well, keep in mind that this is just b over a divided by 2 over 1, right? 2 is the same thing as 2 over 1. So now we have a fraction divided by a fraction, and instead of dividing one fraction by the other, we can say the numerator, b over a, instead of division, multiplication, and then take the reciprocal of the denominator. So we'll do 1/2, or 1 over 2, instead of 2 over 1. Now that we have a multiplication problem, we can just multiply straight across, and we can say b times 1 is b, and a times 2 is 2a, so we get b over 2a. Now the process of completing the square tells us that we always want to take this result here that we got and square it, and whatever we get when we square it, that's the value we want to add to the left-hand side in order to complete the square. So when we square this, we're going to get b times b, which is going to be b squared, and in the denominator, we're going to get 2a times 2a, which is going to be 4a squared. So this is the value we want to add to the left-hand side. So we're going to get x squared plus b over a times x plus b squared over 4a squared. And because we added it to the left-hand side, in order to keep the equation balanced, we also have to add it to the right-hand side, and we'll get plus b squared over 4a squared. Now on the left-hand side, we should be able to factor this into a perfect square. So if we just draw out our factors here, we have x squared as the leading term, so we know we're going to get x times x. Here we have b squared over 4a squared. So we know that the root of that is b over 2a, b over 2a, because b over 2a times b over 2a gives us b squared over 4a squared. So we've got our value set here, and now we're just going to say that this is going to be plus and plus. And if we're not sure about our factoring here, we can always FOIL it back out. We can say x times x gives us x squared. X times b over 2a gives us b over 2a times x, plus b over 2a times x, same thing, plus b over 2a times b over 2a is going to be plus b squared over 4a squared. Then we can say x squared. Here, when we add these two like terms together, we have a common denominator of 2a. So the denominator is still going to be 2a. And then in the numerator, we have b plus b. So we're going to get 2b, and that's going to be multiplied by x, plus b squared over 4a squared. And now when you see we can cancel a 2 from the numerator and denominator of this middle term here, you can see we get x squared plus b over a times x plus b squared over 4a squared, which is what we had up here before we factored. So we know that we've done our factoring correctly. Now over here on the right-hand side, we need to find a common denominator in order to be able to combine these fractions with addition here. So because we have 4a squared in the denominator of this second fraction, and we have a over here, we know we're going to need to multiply this first fraction by 4a over 4a. So we're going to do this here, and when we do that multiplication, we're going to get 4a times negative c, which is negative 4ac. Here we're going to have plus b squared all over 4a squared. Now on the left-hand side, if we go back to the left here, we have two factors of x plus b over 2a. So instead of writing these two factors out, we can get rid of one of the factors and just say x plus b over 2a quantity squared. That's the same way of writing the two factors out. We just use the exponent instead. And now if we take the square root of both sides, so we're going to take the square root of both sides like this. When we do that, and the reason we do that is because taking the square root of a square, those two things are going to cancel, and we're just going to be left with x plus b over 2a on the left. But in order to do that on the right-hand side, we need to make sure we say plus or minus the square root of this right-hand side. So rewriting everything, again, the square root will cancel with the squared. We'll be left with x plus b over 2a on the left, and on the right, we'll have plus or minus, and here's the important part. Remember that when we take the square root of a fraction, we can actually take the square root of the numerator and denominator separately. So we're going to have negative 4ac plus b squared, and in the denominator, we're going to have square root of 4a squared. Now, if we look at the square root in the numerator, notice that we're leading with a negative here. We start with negative 4ac, we finish with this positive term. It would be cleaner to start with the positive term and end with the negative term, so we're going to rewrite this as the square root of b squared minus 4ac instead of leading with the negative. So this square root here will replace this one. In the denominator here, we have the square root of 4a squared. Well, both 4 and a squared are perfect squares. The square root of 4 is 2, and the square root of a squared is a, so we can replace the square root of 4a squared with 2a. When we rewrite this now, we're going to get x plus b over 2a is equal to plus or minus square root of b squared minus 4ac all over 2a. And now, in order to solve for x, what we want to do is go ahead and subtract b over 2a from both sides to get x by itself. So when we do that, we're just going to get x is equal to negative b over 2a, because we subtracted it from both sides, plus or minus square root of b squared minus 4ac all over 2a. And because we already have a common denominator, we can go ahead and combine these fractions, and we get x is equal to, we just add our numerators together, and we get negative b plus or minus the square root of b squared minus 4ac all over the common denominator of 2a. And as you can see, we've arrived at our quadratic formula, which we did just by completing the square of this standard form of the quadratic equation. So that's why this formula works to find solutions to a quadratic equation, because really it's nothing different than completing the square. We think about completing the square and using the quadratic formula as two different things, but really it's the same thing, because this is just a standard formula for the solutions that allow you to go directly to the solutions, as opposed to going through the whole process of completing the square. But really they're the same thing, because in order to arrive at this formula, we just completed the square with the standard form of a quadratic equation.